Okay, so some quick notes is that solving equations can be done in multiple representations. Now, if you looked at the outside of your book yesterday, I don't know if you did, but it says graphical, numerical, algebraic. Those are the different representations that we're going to focus on. And you guys mostly did the numerical, what I saw. A lot of people I did see doing the algebraic. It doesn't matter. There isn't one that's better than the other. They're all super important. But let's talk with numerical. So the numerical ways to solve is to do something called plug and chug, which is what you were doing like when you were just trying one and then trying two and seeing what works for the problem. The problem with that and like on the ACT is sometimes it just takes longer to just plug in everything than it is to try a different method. If you have absolutely no idea what to do, it's definitely something to try. It's just time consuming. And on the ACT, you have a minute per problem, and so you don't want to waste a lot of time doing that if there's another method you can use. All right, and then another numerical method is to make a table and then look for certain values, which is what we did on the donut problem where we were looking for 0. All right, the algebraic way is to use algebraic methods. Now, some of those methods you may or may not remember or like doing, like factoring, quadratic formula, taking square roots. Those are awesome. Algebraic methods, there's a lot more than that, but okay, and then
taking square roots.
Yeah, sorry.
Taking or tracking?
Taking. All right, and then the last method is graphical. And if you have absolutely no idea what to do to solve an equation and you don't have answer choices like a multiple choice, the graphical method is probably the best one because it will solve any equation. So in the graphical method, you find the intersection of two curves. And I'm going to write down the steps in case you don't remember. Okay, so what you do in y1 in the calculator, it equals the left side of the equation. And then y2 is going to equal the right side. Right, and then we're going to do seconds. And then trace. and choose number 5, which says intersection. Okay, so on this penny problem, we're going to actually do it all 3 ways. So on the first part, well, this penny is dropped from the Empire State Building, and the height above the ground in feet after t seconds is given by that formula. So the 1,457 is because that's how tall the Empire State Building is, and then the negative 16 has to do with the rate of gravity. But anyway, you don't need to know that. You have the formula. So we are going to demonstrate how you can use a table to approximate the time in which the penny landed. Now this table is not going to give us the exact time, but it is going to give us an approximate. So I'm just going to go to the calculator and go to y equals, and you guys can do this with me. And we're going to type in 1457 16x squared. All right, and then we're going to go to the table, and when you go to the table, you hit second graph. Now, does anybody's table not have like consecutive numbers? Because my calculus, we kind of changed our table, and I can fix it for you. I just need to know. All your tables good? Okay, so let's scroll until we have 7 through 11. Oops, not too far. All right, I'm going to jot those numbers down. So what these numbers are the height of the penny, however many seconds that the t is after it was dropped. Now, do these negative heights make sense at all?
They've already hit the ground about this time, right?
Exactly. So it's like under the ground, and that's not going to happen. I don't think it's a pretty long way to drop a penny, but so where between what 2 times did this hit the ground?
9 and 10.
Good. Because 0 falls in between those two. We can say the penny hit the ground between 9 and 10 seconds. It's a long time to fall. All right, on B, we're going to find exactly how long it took using algebraic methods. So what I'm going to do is take that equation. I'm going to set it equal to 0. Okay, so let's see what you guys remember about algebra. This is our first day. Sure, what would you do first?
I would subtract 1,457 on both sides.
Good.
And then you're trying to get rid of that square, right?
Not yet.
Not yet.
Get rid of the 16, negative 16 first. Good, thank you. All right, and this is what t squared is. And then how do you get rid of the square? Good job. Now, normally you would do the positive and negative square root to solve this equation. But does negative time make sense in this situation? It doesn't. So we're only doing the positive, but you're going to hear me say take positive and negative square root a lot. But in this case, it's just the positive. And there it is. Okay, and then graphically, we basically just need to look at the graph. Which shouldn't be too hard since we already have it in the calculator. All right. And then we could calculate the zero, but we can look at it and see like that's falling between 9 and 10, a little closer to 10. So I'm just going to do a little graph and say that we verified it using the calculator or using the graph. There we go. Okay, so all three methods. Probably the easiest one and fastest one was actually the algebraic one on this one. It wasn't a super difficult equation to solve. Now, the next equation, you cannot solve it by hand. Like it would be really, really difficult. I don't think it's that you would be able to solve it by hand. So this is one you 100% have to do in the calculator. And so we're going to follow the steps that we wrote over here under graphical. So we'll start off and go to y equals and put the left side in for y1 and the right side in for y2. All right, this time, if we just hit graph to look at it in the old window, it's kind of terrible. You can't really see what's happening. So if you ever want to go back to just the window from -10 to 10, you just hit zoom and then 6. And that's a really good window. So you can see where it crosses. And then we can follow those steps that we wrote a second ago. So it's second, trace, and then 5, enter, enter, enter. All right, you know you have hit enter enough times when it actually says intersection. If it says guess or if it says left or right or something like that, then you haven't hit enter enough times. Do I need both of these for the answer to this equation?
Yes.
Actually, no. And it's because this equation only has x's, so we're just going to give the x. If it had been a system of equations that has x's and y's, we would do both, but we just need the x value. That would have been difficult just plugging in values to actually get that. That would take forever. All right, and then I'm also going to get the other one. Second trace 5. This time I'm going to need to move closer to the other place where it crosses and then enter 3 times. Okay, as soon as you see intersection, you have everything that you need. And those are both the answers. Okay, we have one more to do. So on number 3, an up-and-coming artist has 85 followers on Twitter. This number doubles every week. In what week will the artist first reach 1,000 followers? We're going to use 2 different methods. So I'm going to use a numerical method where we're going to do a table. And it's going to be the week, and then this is going to be the number of followers. And we're just going to do that. Hopefully that'll be enough weeks. So at week 0, how many followers does this guy have? 85. All right, and then this number is just going to double every week. So I'm just I did this earlier. I just multiplied by 2, just kept multiplying by 2. All right, as soon as I got something over 1,000, I stopped multiplying by 2. So the question is, in what week? So what do you guys think? In which week? I would say in the 3rd week, yeah. Or if you are unsure exactly how to word it, you can say between week 3 and 4. But I would say during the 3rd week. All right. And then I don't think solving this algebraically is something we should do like on the 5th day of school. We'll get to where we can solve this algebraically, but we're going to do it graphically. But we have to remember some things about algebra 2. So if something doubles every week, it is a exponential expression, and we have a number, and it's raised to the x. So what is that number? If it doubles, what is the base if it doubles? 2. Okay, so we're going to have 2 to the x, and it's going to be multiplied by something. Any ideas for this particular situation? 85, the initial amount. Good job. I'm proud of you guys. Remember that. All right, and we want that to equal 1,000. Now I could go through some steps. We could solve this using logarithms, but like I said, I don't think we're quite ready for that right now. All right, so what I'm going to do is type it in and find where we intersect. Now, I know I need to get all the way to 1,000, and this graph from the last one is only going to go to 10. So let's talk about this window. This is something I really do want you guys to get a lot better at, which I don't know how good you are at it, but I assume in Algebra 2 you didn't change the window a ton. So right now, I need to get all the way to 1,000. So which one of these min-maxes do I need to change, do you think?
The Y max.
So Y.
So 1100.
That's perfect. Now, really, nothing else matters. I can make it look prettier, but all I care about is where they intersect, so I'm just going to do it. All right. So then we have second, trace 5, and then all I have to do is enter, enter, enter. There it is. I can see exactly where in week 3 that they would reach 1,000. So 3.557, 3.5. So it looks like about Wednesday of that week, a little more than halfway through that week.
Wednesday at like 8 o'clock.
Sure, that's great. Okay, so tomorrow we'll do some problems to practice this stuff.